taking longer to find the answers when you do that, because they're more split up over the whole chapter. So, for the first 5, you have arginine, asparagine, lysine, methionine, and phenylalanine. And you're matching the following amino acids with their anabolic and our anaphylorotic, intermediates. So we're talking about, this one was about the gluconeogenesis, what can create glucose because it comes into the middle of the Krebs cycle. The other one is what we can break down, how we can take it apart, use the skeleton, use the side chain. This question is not about either of those things specifically, it's just that's what these 2 figures are talking about. You go into the middle of the cycle in the same place, so you can use either figure to answer it, but some of these we can't make, right? Some of them are essential, so we can't make them, which is that, you can't see the L, the anabolic, and then whereas the NL-parodic, some of them are gluconeogenic and some of them are not, but they all enter the Krebs cycle somewhere. So that's, I'll put up the figures, if it will let me hop back and forth. And I didn't give you guys the page numbers on these, but they're right next to each other. So figure 1411 and figure 1412 are 299 and 300. And I'll talk a little more about chapter. Okay, chapter 14. Okay, so for the first 5, here we are in the urea cycle. I gave you instructions. Oh no, sorry, that's the second 5. Thank you. Yeah, so the urea cycle is the second 5. So we need 1410. That's this one. There we go. Okay. All right, so remember we looked at this before and we talked about where all of these enter the TCA cycle and how that happens, and the focus is bad. So I can zoom in a little, maybe that'll make it better. So what these questions are asking you is to match them with where they go into the cycle. In other words, isoleucine, I didn't put isoleucine in there because it's got 2 options. I tried to pick ones that only have 1 option to not be confusing. So here's asparagine, right? And then asparagine has to be converted in an intermediate to aspartate, and then it goes into oxaloacetate. Or if you go down here, and then this is flipping over on 300, so this is how you make these from TCA intermediates. These are the ones that we can make because the skeleton is the same. So when you can pull them out, and then we have enzymes and other molecules available to convert them to the non-essential amino acids, right? So we can go alpha-ketoglutarate, right? And then we can go up here, glutamate, and then we've got a bunch of different choices. You can, depending on which enzyme you use and which molecule you're going to attach or remove, you can make a bunch of these different ones. Down here, you've got oxaloacetate, and if you'll notice, this pathway is simply the reverse of that pathway. Here you go asparagine to aspartate or aspartic acid to oxaloacetate. That's when you're going into the Krebs cycle to make energy, right, to go gluconeogenesis. On the other side, when you need to go out and you want to make a new amino acid, this arrow means you can go in both directions, but you go from oxaloacetate to aspartic acid, right, all the way back down the rest of the chain. Does that make sense? So by answering the question this way, you become familiar with the idea that they can hop in and out of the Krebs cycle using amino acids. And that's what I'm saving 14 for. We're going to kind of do an overview of this chapter one more time. And then, I'll go to the doc this will work. Here we go. This is figure 1411. And this is the urea cycle. So because the urea cycle is a circle, you can start anywhere in this circle. I gave you a starting point so that you can put them in order. So even though it's a cycle, you start with ornithine and the cytosol. So we'll go back to figure 1411. And this is ornithine and the cytosol. I asked one question about this thing, ornithine to citrulline, so I started here because I figured everybody would be familiar with it. So you're going to follow ornithine through, down into the mitochondrion, see how it gets converted to citrulline using carbamoyl phosphate to combine, and then back up through and all the way out to where urea is. So you're just going to put those steps in order. Now there are only 5 steps, so not every step in the cycle is there, but let's go through. So So here are our steps. Arginine splits into urea and ornithine. Aspartate leaves the mitochondrion and joins with citrulline in the cytosol to become arginosuccinate. Citrulline exits the mitochondrion. Ornithine enters the mitochondrion, and ornithine joins with carbamoyl phosphate to become citrulline. So I already gave you the first one, right? Because we're starting with ornithine in the cytosol. So the first one is D, because ornithine was in the cytosol, and then it enters the mitochondria. And then you can follow the arrows around to see what happens next. So what happens if we start with ornithine and it's in the cytosol, and then it goes into the mitochondria, and we still have ornithine, right? So the next one is ornithine joins with carbamoyl phosphate to become citrulline. So you're following the circle directly around. So we just did the first two steps. The first step is ornithine enters the mitochondria, right? And then ornithine joins with carbamoyl phosphate to become citrulline. And then you're going to take the other three from there. You're just going to follow the arrow straight up and find out what happens next. And then follow this arrow straight around and find out what happens next. There are a couple more steps that I put in there, but I tried to stick pretty close just to this pathway right here. We're going to talk a little more about this, because that's the last part of the quiz. But so does everybody get what we're doing with the matching? Okay. And then our last one. Okay. So we've got 5 true falses. And then, and again, I usually pull these out of a big